Let's see, what do we have here? Thank you to people who filled out my Google Forms survey. I appreciate it. If you haven't, you still got a lot of time. You don't have to put your name down if you don't want to. It is super helpful for me to hear what is going well and what isn't going well and what could be going better and what is just a disaster because of the situation in general that none of us can fix. So if you have time and you have things to say and you want to fill it out, that's great. Next up, we do have class on Monday. So that was kind of an optional. I know some professors are having class and some professors are not having class. We do. We are going to have class on Monday at the regular time, and that is reflected in the schedule that is online on Moodle. So that's the next thing. Next test is a week from this Friday. So Friday, April 17th is the test on chapter 4. I am trying to figure out what I want to do for review. Normally I would have you do review group work, but I'm not entirely convinced that's going to be super productive. So let me think about that. I'll have an answer for you on Monday. We've got some time. Monday and Tuesday are going to be 4.6. And then Wednesday would be whatever kind of review we're doing. So let me think about what I want to do for review group work. It might end up being review group work and having even breakout rooms, I'm not sure, but we'll figure something else out there. Those are my reminders. Any other introductory questions before we finish up section 4.5 today? Procedural, content, anything else? Other ones before we get going? Okay, then let's do a quick review of what we were doing yesterday. Remember, we had these new functions called unit step functions. So unit step function. Remember that there were two ways of notating it. U sub A of t. You could do it that way, or you could do U of t minus a. We could do it either way. Both of those ways work. And what that is equal to is 0. Sorry, let me close my email. 0 if t is less than a, and 1 if t is bigger than or equal to a. So this was that unit step function that we talked about yesterday. Daniel, question?
Yeah. I'm sorry. So for one of the homework things, when you deal with the reverse, so if it's like 1 if t is less than a and 0 if t is greater than or equal to a, is that just like t plus a or something like that? I don't know.
You could do a negative if you wanted to, or you can do what we did yesterday with subtracting and turning into a new function. So maybe hold your question, because we're going to do a differential equation today, and that might answer your question when I do another example. If it doesn't, we'll come back to it. Okay?
Okay, thanks. Yeah.
Okay. All right, and so then remember, we can do the Laplace transform of this. So the Laplace transform of u sub a of t is boring by itself. So we don't usually do the Laplace transform of just u sub a of t. We do the Laplace transform of u sub a of t times f of t minus a. That is going to be e to the negative a times s, except I don't want a fraction. So that is going to be e to the negative a times s times capital F of s. And then we can go backwards also. So the inverse Laplace transform of e to the negative a times s times capital F of s is u sub a of t times f of t minus a. And remember, that just shifts. So this is 0 if t is less than a, and it's f of t minus a if t is bigger than or equal to a. Oh, I must have done something wrong because 2 people raised their hand. Who do we got? Let's see. Stuart, yes.
Mine wasn't something you did wrong. I was just wondering, with on the homework, it had one where you had to split it, because it was like there was subtraction on the top of the fraction. So
Yes,
splitting it into 2 fractions. Do you bring that into the same range?
Yes, we'll do that today. We'll do one where we have to split it today. Yep, that will hit my
Okay.
example. Okay, and Daniel also.
Sorry, I must have just not lowered my hand from last time.
Okay,
That's
all right,
weird.
so we're good? Everybody's good?
Yeah.
Okay, awesome, super. Okay, we did not do any examples with differential equations yesterday, so let's do one or two of those today. So let's start a new screen. We're gonna do a differential equation. Here's what we've got. For example, we haven't done one of these in a while. X double prime plus 5x prime plus 4x equals 1 if t is less than 2, 0 if t is bigger than or equal to 2. And then I've got that x naught is 0 and x naught prime is 0. And we want to solve this. X double prime plus 5x prime plus 4x equals this piecewise function, 1 if t is less than 2, 0 if t is bigger than or equal to 2. And if I'm going to solve a differential equation using Laplace transforms, I have to have initial conditions. So we've got x naught is 0 and x naught prime is 0. Okay, so let's do the transform of this right-hand side first, and then we will deal with the rest of this. So this is of the wrong form. We'll call it g of t. So g of t is 1 if t is less than 2, and 0 if t is bigger than or equal to 2. That doesn't work. We can't do that. We dealt with this yesterday. We need to have a 0 on the top. So instead, let's look at, if we do an instead, we will do g of t minus 1. And so this is going to be 0 if t is less than 2, and negative 1 if t is bigger than or equal to 2. So that's my instead, because I need a 0 on the top. So we'll do g of t minus 1. My a value is equal to 2 in this case. Got a equals 2. We're getting good at this. And so what we need is we need f of t minus 2 to equal negative 1. That's what we need. We need f of t minus 2 to equal negative 1. There are no t's over here, so we can just have f of t equals negative 1. If there were t's on the other side, I would plug in a t plus 2. Remember, we do this backwards, but there's no t's, so f of t is just equal to negative 1. I don't have to worry about plugging in my t plus 2 because there's no t's. So therefore, my transform is going to be e to the negative 2s times negative 1 over s. Transform of negative 1 is that negative 1 over s. We can rewrite this if you want to as negative e to the negative 2s over s. So that's my transform, almost. Negative e to the negative 2s over s. But that wasn't what I was originally looking to find. So what I found, if you look at our revamped left-hand side, was capital G of s minus 1 over s, right? We had g of t minus 1. So the transform of that is capital G of s minus 1 over s, since I had to subtract. And so therefore, the transform of the right-hand side, if I get capital G of s by itself on one side, is 1 over s minus e to the negative 2s over s. That's my transform of the right-hand side. 1 over s minus e to the negative 2s over s. I'm going to stop sharing my screen just for a sec as soon as you get caught up writing, so you can give me a thumbs up that this is good. This is what we did yesterday. All right, so are we good there? Yes, that is helpful. That was yesterday's. We're good? Okay. All right, let's go back to, I'm going to start a new whiteboard because I'm running in a room here. And we will go ahead and do the transform of the right-hand side and the left-hand side and start our differential equation. So here's where we're at. X double prime plus 5x prime plus 4x equals, I'm just going to call it g of t. X naught is 0. X naught prime is 0. All right, so transform of the left-hand side, we haven't done this in a while. s squared, capital X of s, minus 0s minus 0. I don't have to write those in, but I am because we haven't done this for a while. Plus 5s, capital X of s minus 0. Plus 4, capital X of s. And then I'll do the right side in just a sec. S squared, capital X of s, minus 0s minus 0, plus 5 times s, capital X of s minus 0, plus 4, capital X of s. And this equals what we just found. So this is 1 over s minus e to the negative 2s over s. That's what we just found on the previous slide. 1 over s minus e to the negative 2s over s. That was what we did on the previous slide. Okay, so solving for X of s. This was step number 1. Remember step number 1 in doing differential equations with Laplace transforms. We're ready for step number 2, solving for capital X. So doing some algebra. Capital X of s is, we'll do it this way, 1 minus e to the negative 2s over s times s squared plus 5s plus 4. So I'm going to make those into one fraction and put everything over a common denominator. 1 minus e to the negative 2s over s times s squared plus 5s plus 4. And then that denominator factors, so we can do 1 minus e to the negative 2s over s plus 4, s plus 1. Okay, so now we're ready for step 3, which is the hard step. That's always the hard step, step number 3. I am going to split this into 2 because we're subtracting in the top. So I'm going to split this into 2 and do 2 different inverse Laplace transforms. So first one over here is going to be 1 over s plus 4, s plus 1. I'm going to do the inverse transform of that one first. We have choices. We have an extra s in the denominator. So we could find the inverse transform of that and then integrate once. We could do it that way if we wanted to. Or we could do partial fractions with 3 pieces. Either way will work. If we were in class and I were feeling more confident about my teaching abilities, I would let you give me a choice. I am not doing that today. We're going to do partial fractions. You could do it the other way if you wanted to. So if you solve for a, b, and c, you are going to get 1/4 over s plus 1/12 over s plus 4 minus 1/3 over s plus 1. Partial fractions, a, b, and c. Go look at my notes online if you need to. That is where you're going to get those coefficients. 1/4 over s plus 1/12 over s plus 4 minus 1/3 over s plus 1. Okay, front of your book, do an inverse transform of that one for me, please. Front of your book, inverse transform, it's got 3 pieces. So go ahead and do an inverse transform of all 3 of those pieces, please. I'm getting 1/4 plus 1/12 e to the negative 4t minus 1/3 e to the negative t. 1/4 plus 1/12 e to the negative 4t minus 1/3 e to the negative t. I think we're good with that? Okay. All right. Now, the other thing we have to do is the transform of this other part here. So we also need to do the inverse transform of e to the negative 2s over s plus 4, s plus 1. And then I'm going to subtract the two pieces. So I know I have a minus that I don't have out in front right now, but I'm going to subtract my two pieces with t's when I'm done. I'm just leaving the minus off for this particular instant, and then I'm going to subtract when I'm done. Okay, we can deal with a little bit of this with what we already did. So this is e to the negative 2s. We can do 1/4 over s plus 1/12 over s plus 4 minus 1/3 over s plus 1. There's no reason to reinvent the wheel and do partial fractions again. We already did partial fractions once, so we might as well use what we did for partial fractions once. So we've got our partial fractions decomposition that we did once. And then what we have to do is remember, okay, what happens when I have an e to the something out in front? How do I deal with that? That was yesterday's. So this is my a value of a equals 2, positive 2, because it's e to the negative as. So my a is equal to 2. And my inverse transform of this part is then going to be u of t minus 2 times f of t minus 2, right? That's my inverse transform from what we talked about yesterday, from what we talked about at the beginning of the class. And so I want a u of t minus 2. You could also say u sub 2 of t if you wanted. And then we're gonna have 1/4, just 1/4, that does not have a t in it. So there's nothing that I need to worry about there. So we've got a 1/4 plus 1/12 e to the negative 4 times t minus 2. Normally it would be e to the negative 4t, but I need f of t minus 2 in this case. So I got to put a t minus 2 in, minus 1/3 e to the negative quantity of t minus 2. Normally, it would be e to the negative t, but I got to put in a t minus 2 in this case. So it's e to the negative t minus 2. And then I'm on a whiteboard, and this is terrible. It wouldn't even be any better on the chalkboard. So let's call this part number 2. Can we please? And we're going to call the part that we did in the first place number 1. So we've got a number 2 and we've got a number 1. If I label both of these, I just don't want to rewrite them both again on the whiteboard. And so therefore my answer, my inverse Laplace transform, is going to be part number 1 minus part number 2. So that's my answer. You can rewrite it all with part number 1 and part number 2. I'm not great on a whiteboard anyway, so this is a concession to please, please, please let me just not have to rewrite all of it. Jason, question?
For number 2 there,
Yep.
And we have the 1/4.
Yep.
Why wouldn't we have a t there even?
So think of your inverse transform, right? Your inverse transform of 1 over s is just 1. It's not t.
Okay.
Right? So therefore it's just 1 times 1/4. So we don't have any t's here. You get a t if you would have a 1 over s squared. That's when you would get a t. Make sense?
Yep.
Cool. Okay. Other questions? Other things? Other questions on this one? There's a lot going on here. This would usually take up like a board if I was doing it in class. There's a lot going on. Let me stop sharing my screen so I can see all of you. And you need to finish copying. Do I need to share my screen again so you can finish copying? Are you okay? Okay, mostly, kind of, yes. All right, help me out. Thumbs up, yes, this example makes sense. We're doing okay. We're pulling together stuff from previous that we've done for a while. Yes, we're okay. Yes, all right, cool.